This video is about Skyvia's control flow and data flow tools. They are advanced data integration solutions that allow implementing complex data pipelines. In this video, we are going to automate the following scenario. Users register on a website which runs on top of an SQL Server database. The data about new user registrations must be loaded to Google BigQuery for data analysis. Additionally, we need to update a Google Sheets report with data about new user registrations. Let's start creating a control flow. A control flow allows you to implement custom logic, run tasks in a specific order or depending on specific conditions. You design control flows by adding control flow components to the diagram and configuring their settings. Control flow components can be divided into core components, control blocks that represent control flow logics, and actions, components that can perform interaction with data sources and modify control flow variables. We are going to create a simple control flow that runs two data flows, one after another. The first data flow loads data from SQL Server to BigQuery, and the second updates Google Sheets report. Let's name the first data flow load to BigQuery and configure it. You design data flows as well as control flows by adding components to the diagram and connecting their outputs to other components. Data flow has the following components. Source queries data from a data source. Target loads data to a data source or modifies data in it. Split directs all the input records into multiple outputs or depending on the specified conditions with conditional split. Bufferizer caches input records and outputs them in batches of the specified size. Row count counts processed records and stores their number in a variable. Lookup enriches loaded data by querying matching records from another data source. Extend adds calculated columns by applying expressions with various functions to existing columns and variables. Value selects a minimal, maximal, first or last value of an output column or specified expression and stores it in a variable. Let's get back to our use case. The first data flow will load data about new user registrations to BigQuery. The table with registered users has an identity primary key column. Its value grows by 1 for every new user. This means that we can store the max value of this column and the next time process only records with a value larger than the saved one. We can use a parameter to store the max value of the ID column. Data flow and control flow parameters store values between the package runs, so we create an int32 parameter named maxID here. The first run should load all the records, so we set it to 0 first. Every data flow starts with querying data from the source, so let's add a source component. First, we need to select a connection or create a new one. Let's select our existing SQL Server connection. In the source component, we can either execute an SQL statement, selecting data, or build a query visually. Let's enter our select statement. After this, we need to map the action parameter maxPreviousID that we used in the statement to the package parameter maxID. Let's open the mapping editor and specify the mapping. After we query data, we need to store the maxID of newly queried records in the parameter for the next time. We can use a value component for this. Then add the target component to load data to BigQuery. Let's select our existing BigQuery connection and insert action. Then we need to select the target table and map action parameters, which correspond to the target table columns. If they have the same names as the input columns, we can just click Auto Mapping and they will be mapped automatically. After this, we have a fully working data flow and we can run our control flow to load data to BigQuery. However, if we run it in this state, its run details will show 0 success rows and 0 failed rows, despite actually processing rows and doing its job. We need to count the corresponding records in data flow and specify them in the result settings. First, we need to create variables to store the number of success and failed rows. Unlike parameters, variables are used to store values only within a data flow run, but don't store their values between runs. Then we add the row count components that will count process rows and record results into the corresponding variables. If you need additional error information, Skyvia allows you to create error logs with per row error messages. Now let's load data to Google Sheets source. Return to parent and create a new data flow. Let's name it Update Google Sheets Report. As well as in the first data flow, let's add a source component that will query aggregated data for the report from BigQuery. We will use execute command action again with SQL query, querying the number of registered users per month and year. In Google Sheets, we will update old rows for past months, and we need to add a new row when there are user registrations happen in a new month. So first, we need to check whether the Google Sheets report already contains a record for the corresponding month. We can use the lookup component for this. Lookup allows you to query matching records from another data source and add columns from these records to the input records. We will use the lookup action here. Here we select the required sheet and the key column, month and year. In result columns, select row number. Let's also map the parameters corresponding to the key columns in the matching source columns. We add the row number of Google Sheets rows to our flow. With the first or default behavior selected by default, lookup sends all the input records to the default output, and if matching records are not found, it fills the added columns with nulls. If multiple records are found, the first is selected. After the lookup, the Google Sheets row number value is added to records for which the match is found. For records with no match found, a null value is added. We need to separate our records depending on whether the match is found or not. For this, we will use the conditional split component. We will direct records with null numbers to the insert output, and records not matching this condition will go to the default output. Now we need to add target components that will insert and update data in Google Sheets. Let's add components and connect them to the corresponding outputs. For the update action, we need to specify a key by which we select a matching row to update. That's all. We can now save and run our control flow. After the run is finished, we get the following report in Google Sheets. Now we can run this control flow anytime to update data in BigQuery and Google Sheets, or even schedule it for automatic execution. Skyvia offers powerful scheduling settings, which allow creating almost any kind of schedule. You can schedule your integrations to run every day, on specific weekdays, more often than once per day, every few hours, or even minutes. In a similar way, you can automate other cases of your data loading routine with Skyvia and enjoy having up-to-date data wherever you need it without any effort.